Hi guys, my name is Parag Pal and welcome back in the lecture number 6 of steel structure. So in this video, we are gonna calculate the bolt value, okay, for this particular sections, okay, and we'll identify the number of bolts required, okay, for this numerical. So this is really very interesting numerical for all of you, okay. Please watch this video till the end so you can understand the step-by-step procedure to calculate the proper bolt value and the procedure to do the same, right? So let's get started. So first of all, let's go through the numerical. So numerical is determine the bolt value of 16 mm dia bolts of 4.6 grade used to connect two angles ISA 80 by 50 by 6 mm. Okay. Place back on the both sides. So see, this is very important sentence. Back on both sides. It means this is a representation. Okay. So this is angle number 1. Okay. This is angle number 1. And this is angle number 2. Right. And this is the back side of the first angle. This is the back side of another angle. Right. I hope you get that one. Right. Now this is very important sentence. Okay. Now here it is also one of the important sentence. 8 mm thick gusseted plate is provided. It means this section, this plate, okay, this plate is here. It is a gusseted plate, okay, to which this both angles, okay, are connected. Understand? So this is a numerical. So let's first understand the numerical so you can easily solve the numerical. Also determine the number of bolt. We need to calculate the number of bolt required for the joint when it carries a direct, see, factored load they have provided of 106.5 kilonewton. So we have lots of given information over here. Now we need to draw a sketch of designed connections. So here we need to draw the design connections, which is this kind of diagram we need to draw here. Now let's do the solution for this. So we have some given data. Fu is a 410. Why? Because we have here grade as a 4.6 grade over here, right? So 4.6 grade we have, okay. So we got Fu as a 410, FUB as a 400. Now area of bolt we need to calculate, okay. So how we can calculate that one? 157 mm square for the 16 mm diameter of bolt, that is this is A and B calculated from this formula, 0.78 into AG. So AG is nothing but pi by 4 into diameter square. So we have 16 mm diameter of bolt. So we kept here, okay. So pi by 4, 0.78 into pi by 4 into 16/7, we got 157 mm square, okay. So we just copy that 157 over here. Understand? Let me just remove everything so I can provide you these notes on my website civilnotes.com, so you can easily view that one, okay. Right. Now you might be wondering how this FUV is calculated. So you can watch my lecture number 1, lecture number 2, because all these things is calculated with respect to this 4.6 grade. You understand? Right. Now after this, once you do all these functions, then you need to understand that the DH and DO. So you can see 16 mm diameter, then the diameter of hole will be 16 plus 2. So it will become 18 mm. Okay. Now partial safety factor for the bolt and angles is 1.25. So that is our standard value we are considering. So this is the basic data we have. And also we have the information that the gusseted plate is having the thickness of 8 mm, right? And they are connected on the side to side, like back side of the bolt. So this is our answer actually, okay. But now we need to understand what would be the edge distance. This distance we need to calculate. This distance we need to calculate, okay. That is what our design. So let's do the design. So first of all, after doing the basic data calculation, we need to understand the double shear strength of the bolt. That is the first step. So we need to calculate VDSB. So VDSB formula is very simple, VNSB upon gamma MB. But here we have two number of balls, okay, we are calculating double share, so just multiply it with the 2. Okay, so 2 into FUB upon gamma 3 under root 3 multiply by n into ANB plus NS into ASB upon 1.25. Now put all the value, but NS will be 0 because we are not calculating for the share, we are calculating for the normal hole, right? So 2 into, put all the value over here. So we got VDSB as a 58.01 Newton. See, this is very simple concept. Okay, we are calculating for double share, right? Because here we can see this is our formula. If I just remove for this one, so this is for the single share and this is for the double share, because we are multiplying for the 2 bolts. We are calculating for the number of bolts, right? So I'm multiplying with the 2 bolts. Okay, so okay, you can see why I'm doing this double share, because the angles are connected on both side. Okay, the angles are connected on the both side back to back of the gusset plate, hence bolt will be in the double share. Okay, that's why we are using the double share bolt, right? Now, so VDSB we got. Now let's identify the bearing strength of the thinner plate. So for that we are calculating VDPB. So VDPB formula is very simple, guys. VNPB upon gamma MB. So the formula is simplified that 2.5 into KB into D into thickness into FUB upon gamma MB, right? So as we all know that the formula for the KB, to calculate the KB, we need to calculate all these 4 parameters, and whatever is the smallest things, we need to take that one. But before that, as you can see, we need to calculate pitch distance and the edge distance. So to calculate the pitch distance, the formula is 3 into diameter and edge distance is 2 into diameter. So 3 into 16, which is diameter of the bolt, and 2 into 16. So we got pitch distance as a 48 and edge as a 32. So we are making round up to the 50 mm for the pitch distance, and for edge distance we are making it as a 40 mm. Understood? Now let's put all the value in this KB value calculations. So for this, the first formula is edge divided by 3 into DO. So it becomes 0.74. Then pitch divided by 3 into DO into 0.25. It becomes 0.67. Then next is FUB upon FU, which becomes 0.97, and the 1 is a unit value. So the least is 0.67. So in this situation, we need to consider KB as a least value. Okay. So when I'm putting all this value in this VDPB equation, you can see I'm getting VDPB as a 70.32 kilonewton. So you can see the bolt value should be at least of VDPB and VDSB. So VDPB is 70.32 and VDSB is 58.01. So least value is 58.01. So that's why our bolt value become 58.01. Now let's calculate how many number of bolts we require. See guys, it is very simple. Whenever they ask you to design the number of bolt or bolt value, it means you need to calculate the how many number of bolt you require at what edge distance and what will be the pitch distance, right? Now you can see to bind these 2 angles on a single gusset plate, we required how many number of bolt, that will be calculated with respect to the bolt value. So now you can see the bolt value will be calculated by what is the factored load divided by your bolt value. So in our numerical, the factored load is 106.5 kilonewton, right? So 106.5 kilonewton is our factored load. So you need to divide that with the bolt value, which is 58.01. So you will get 1.83. It means we cannot provide 1.83 bolt. So we can provide the round of nearest value, which is 2 number. Okay. So minimum you need to provide 2 number of the bolts in your this design to bind these 2 angles with each other. Understand? Now after this, what is a minimum pitch distance you can apply? Now you can see guys, here pitch distance we are considering 50 and edge distance as a 40. But here we can again calculate what is a minimum pitch. So minimum pitch distance can be 2.5 into diameter, and edge is we are considering the 37 meter. So 30 meters. So how it is calculated, I'll explain you. Whatever the pitch distance 0.25 into D, which is the minimum one, it become 40 mm. Reduce 10 mm from that. So that is the 30 mm is the edge distance. So with respect to this calculation, we are coming on this solution that this is our design, whereas we can put this 2 number of bolt here, 2 number of bolt, okay, with the edge distance of 30 meter and the pitch distance of 40 meter. Okay, so that is a solution and that is our calculated value. I hope you understand this situation. Okay, so this is a very simple numerical I have explained to you, and I hope you do the good practice and you will definitely get the good result in your examinations. Have a nice day, guys. Bye bye.